All right, so it's day 21 of 100 Days of ML, and today I'm going to continue reading chapter 8, which is model development using TensorFlow Serving. I finished half of the chapter yesterday, and I'm going to be finishing up the rest of the chapter today and continuing to read online resources on TensorFlow Serving. I did watch a wonderful video on YouTube on TensorFlow like pipelines. I'll pull that up at the end and maybe show that. I don't know if I currently have it in history. Let me just open it up and boom, boom, boom. Okay, so this is a video I watched. It's titled TFX Production Pipelines with TensorFlow, and it's about a 40-minute video which goes over pretty much the entire book, but in a very, I guess, basic abstract definitions. They skip over like a lot of stuff which you wouldn't get if you don't read the book, but it gives you a good high level like overview of like what the tools are and what they do, and some boiler like example code on how to execute each component of the pipeline. And they have a small demo. They don't really explain the code in the demo. They just go through it really quickly. And yeah, that's pretty much it. It's like the entire book just summarized in like 40 minutes ish. Pretty neat. But now I'm going to switch gears. I'm going to finish up reading this chapter. Most of this video is just going to be like a vlog, like a documentation log of me finishing up like reading, building ML pipelines. And I think from tomorrow onwards, what I'm going to do is plan out a production level ML product because I'm tired of reading books. It's been a lot of reading for the past few days. So I'm going to try to put to use tools and knowledge that I've learned in this book and the previous one as well, and try to build some sort of small production level ML product that I can deploy onto the internet with an entire pipeline developed. So I'll be working on that, and I do have to get a domain name for my website. I keep procrastinating on that. But without further ado, I'm gonna start reading and shift gears here. Okay, so I just finished my reading. It was pretty light, to be honest. The rest of the chapters was, let me recall. I mean, the rest of the topics were, well, first it started off with the differences between GET requests and gRPC, I think. Two different types of requests. And then gRPC, yep, gRPC. And then we went into like requesting model metadata just to get that over with, and then model A/B testing, figuring out which versions of the model. Like if you have a new model and you want to put it into production, you don't want to test it out by basically sending every single user to this new model. What you want to do is maybe send 10% to the new model and have 90% use the older secure model. That way you don't have unhappy customers. But you can also get real world data on how your model is performing. After that, let's see, batching. So one way of getting the requests is sequentially. You could have each user request, and that would start up a node in the server, and that request would be processed sequentially one at a time. Another way you could do it is batching all of the requests together. So instead of running one task at a time, you're going to take about like, let's say 5 users, for example. You take 5 users and put them into one batch and run it parallelly on the server. This optimizes the GPU and CPU, so it optimizes your hardware, but it does increase latency for response. So it's not a great idea if you're serving your model online, but if you're serving your model offline and you're limited on like resources and you also have a large influx of data requests, then it's better to batch your requests. It also went into other TensorFlow serving optimizations and provided different alternatives to deployment. Finally, it went into like deploying using cloud services. So Google Cloud, AWS, and the case that they used was using AI Platform, which is actually renamed now, I think, into it's called like AI Vector or something. Let me just double check. This is on Machine Learning Monthly. Yep. So AI Platform is now called Vertex AI. So the Google Cloud for Home for AI, previously known as AI Platform, has been renamed to Vertex AI, and it has like more features now, which is nice. Next up, yeah, it just talked about setting up AI Platform and deploying your model using that, and that was pretty much the end of the chapter. So now that I've finished chapter 8, I'm done with the entire pipeline structure. And what I've learned so far is that the pipeline is very important if you're developing like a model for a company or some sort of very large scale application. It's not something you could fully utilize if say you're doing a personal project. On this, I don't know, you want to get practice with all of the materials, all of the tools. But even then, it's a very complicated and expensive and time-consuming goal to kind of build out this entire pipeline. So keeping that in mind, I have to be sure to, when I'm planning out the product that I want to build, I want to make sure that I don't overestimate my resources and plan accordingly. Till then, I'm going to do some initial research on, I don't know, maybe existing ML pipeline projects and stuff like that. I don't even know what to search. Let's start with TensorFlow serving. Can start here. So they have TensorFlow has great documentation on TensorFlow serving. I think I've read this before. So I do need to keep in mind that if I do want to deploy and put this online, I do have to kind of start up another GCP project and make sure like that billing comes under the free credits that I currently have. Currently, I have deployed one of my products, Textizer. If I can get the link to that. Oh, that's my paper. Here we go. This is the website. So this is currently deployed on Firebase, and it uses GCP for the backend. And it's very slow. What I've learned is that the REST request latency takes about like a few minutes to start up because of the cold start. But I mean, if you do want to make it faster, it would just become more expensive. So I'm trying to keep the cost low. And by doing that, I had to increase the request latency. So on the back end, basically, it just sends a REST request to my GCP Cloud Run, and once that request comes in, it's going to start up a container, and using that container, it runs my it's a Docker container, so it has all of the code required for running, getting the request, loading in the model, pre-processing, and serving back the response. So it does take a very long time to like respond, but I guess that's what you get for free services. So I also need to make the decision whether I want to use my own server or if I should continue using like cloud services. So there's a lot of things to plan out for tomorrow. And okay, I think I need to do a lot of research on how to set up like the project and what I want to do. Like, do I want to do an image classification or something more simple? And what my model is going to be and where my data is from, all that stuff. To be honest, I think I'm just going to do a simple text-based regression model. So look into models to deploy. And I'll have to pick one. And then after choosing the model, what I can do is kind of just create the architecture for the pipeline. That includes like what technologies I'm going to use, what components, and whatnot. Never mind. I'll just keep this like that. So I think I got my response here, and the summary response in I forgot to print it here, but it basically gives a JSON request, a JSON response, and I just parse the JSON and display the value. Very simple website. So, oh yeah, I gotta build the front end. So choose how to build front end. I'm also just gonna use Streamlit and keep it very, very simple. What else? Architecture is the main part for the pipeline, and also CI/CD. I need to make sure how to integrate CI/CD. So what I'm going to do is most likely have a GitHub repo for my project for the front end maybe. And I don't know if I want to divide the front end and back end code into two different sectors or how I do this. So in the book, it recommended that you should have like a model server be separate from the front end application. But there's also another way where you can combine both the backend and front end into uh, a Flask API, where the Flask web framework is deployed on, for example, a cloud container. But in that container, you also have the code for the the model deployment. This container would end up becoming a very large container since you have both the front end and the back end both combined into like one sector. But it becomes much faster and much easier to operate because all of the code is in one location. Otherwise, if you have a model server, you have to send a REST request or gRPC request to your model server and have that server start up and then execute the code and then return back the prediction. What I think I'll do is most likely use the model server, but I do have to make the decision. I have to look into like the pros and cons a bit more, and especially take into consideration of like the resources I have at hand. And I'm not sure, does the deployment really matter for me? I think the main part here of this like product that I'm going to build is to focus on the pipeline. So I think I could take it easy on the deployment. Okay, so I'm going to check this out for learning about pipelines and also CI/CD. Privacy and protection, I think that's a whole chapter of its own. I have to read that. MDP, Markov chains, okay. AWS, generative learning. Apache Beam. Yeah, and I have to figure out what type of like flow I want to use, either Apache Beam or Airflow or Kubeflow. I think I'm going to stick to Apache Beam for the pipeline. So what orchestration tool? Okay, that's a lot of things to do, and I'm not sure if I'll finish it in one day. So I'll take a couple of days to I think even the day after, I'm gonna continue planning it out, making sure I have the project in mind before trying to dive in. So I think in terms, I do also have to figure out like in what order to start. So I don't want to start from the deployment because I always make that mistake. I start backwards and it doesn't go too well. So I have to be sure to like get the model ready, build the pipeline, and then focus on deployment. So create order of events or like an agile and manage my tasks there, or even like GitHub projects. They have a neat way to plan out the project and track progress. So maybe that set up GitHub project. So yeah, this is a lot of things. I mean, whatever I do finish, I'll finish here, and whatever I don't, I'm just gonna push it to day 23. The rest of today, I'm gonna spend a few minutes just going through online resources and looking at like what other people have done and try to see, okay, like what is feasible and what's not. I don't even know how to like name that. So I'm just gonna leave it empty for now. Okay, major changes. Cool, cool. Am I on target? So next up would be CUDA and hardware accelerators and figuring out how to do that. That's coming up. I'm still on day like only 2023, so I do have a lot more days to do this. So I think the product will end up taking up a very long time, maybe like a week or two. So suppose I finish planning by this week, and I'll give myself ample of time to finish planning, so I'd have enough time to really think the project through. And I'll give myself maybe like 2 weeks time to build it. That would be around like 14 hours. 14 hours to build the product in total. And my billing ends on the 30th. So I'll have 1 week to kind of test and deploy and make sure like the product's kind of like working. After that, on the 29th, I will be ending my trial. So that's around 3 weeks for this. Just about like 21 more days, which seems pretty reasonable. I mean, after that, I'll be at 40 something days, and I'll still have like pretty much more than half of 100 days of ML left for CUDA. So I'll have to add a lot more challenge goals into this project. Oof, okay. Well, one step at a time. Let's see if we can build this project in 2 weeks. Not even sure if it's possible. But if I'm consistent and spending an hour a day, I think it should be very easy to set up. Okay. And let me try to find projects that I can refer to. One, definitely go into his repository, MLOps. He uses MLflow for deployment. I think I'm going to be using TensorFlow serving. So yeah, I have to figure out all of this structuring and how I want my repository to be set up to make the repo very clean and thought out. Because if I just start adding code to my repository, it's just going to become very messy and unorganized. Okay, I'll continue the rest of my search offline.